Very good. So what about these rational numbers? Well, if you consider a polynomial, so we're going to focus on polynomials. Say you have p of x is equal to x to the fifth minus 3x cubed plus 6x squared minus 7x plus 6. Okay? And you're wondering what the solutions to that polynomial are. So I just got done having you graph polynomials, right? And you graphed them. They went through the x-axis wherever it had a solution or a zero. So I want to find the solutions or the zeros to this. Well, we got the quadratic formula, right? Well, they have a formula for the cubic. It's pretty lengthy. The formula for the quartic, it takes up a couple pages. It's kind of difficult to even look at. They've actually proven that once you get to the quintic, there's no way to come up with a formula on how to solve the quintic. Can't do it. Not possible. So how would we find the solutions to something like that? Just rip up the paper. Okay. All right. Oh my God. All right. Okay. We don't give up. We don't tear up the paper. We use the rational roots theorem. It's super easy. Let me show you how it works. What are factors of 6? What are factors of 1? It turns out that if there are rational solutions, that they are these numbers divided by these numbers plus or minus. I'll show you. It's super easy. Rational root theorem says, suppose that you have a polynomial of this form. Now, don't be scared when you see this form. What happens to the exponent every time? Yeah, it's going down by 1. So it's a descending form, and it's got these coefficients out front. The only coefficient to focus on is that one, and then the constant at the end. So if a sub n has factors of, we'll call it q, and a sub 0 has factors of what we call p. If the polynomial has any roots that are rational, they are of the form plus or minus p divided by q. Super easy, super powerful. Watch. Flip your page over. X cubed minus 7x minus 6. Does it factor? Possibly. I like the answer because the fact is it does factor. We can't see how it factors. I don't see how it factors, but yet it does. And before today's over, you guys are going to look at that and say, I have no idea how to factor that, but now I do. And not only do I know how to do it, it's super easy. What do we do to factor that? We employ the rational roots theorem. What's the degree of the polynomial? So you'll end up with 3 factors. P's are factors of the last term, which are? Q's are factors of the front coefficient. My choices for possible rational roots are the p's divided by the q's plus or minus. 1 divided by 1 is 1, so I list plus or minus 1. 2 divided by 1 is 2. I list plus or minus 2. Plus or minus 3, plus or minus 6. Look at what we just did. We took an infinite set of numbers and we reduced our choices down to 8. I guess we still got 8 choices. That's a heck of a lot better than infinity. Which one do you think works? Which one do you think is a solution? You think 6 works? I don't want to try plugging in 6. 6 cubed is like 216, super big. 2? Okay, let's try 2. 2 cubed is 8 minus 7 times 2 is 14 minus 6. Smartboard got dumb all of a sudden, but does that give me 0? It does not give me 0, does it? 8 minus 14 is negative 6. Minus 6 is negative 12. So 2 didn't work. Sorry, Garrett. Somebody else give me another option. 3. Okay, 3 cubed. 27. Minus 21. Minus 6. Does that give you 0? Give it up for Carson. There are 3 solutions. But here's the key. Carson found out that 3 works. So here's what I want you to think of. If 3 is a solution, what's the binomial that divides evenly into it? So, for example, a binomial would be like x plus 1 or x minus 10. What's the binomial that divides evenly into it if 6 is a solution? If 3 is a solution, sorry. X minus 3 divides evenly. You guys learned on Friday how to divide polynomials, right? X minus 3 divides evenly. So what I'm going to do is I'm going to divide this. 3 goes into, and I drop the 1, the 0, the negative 7, and the negative 6. Drop the 1, I get 1. Multiply, 3. Add, 3. Multiply, 9. Add, 2. Multiply, 6. Add, 0. So we started out by saying that it factors, but we don't know how. Well, now we know how it factors. X minus 3 times x squared plus 3x plus 2. That's how it factors. We didn't know. We couldn't see it, but it does. It's right there. So we got x minus 3 times what? X plus 2 times x plus 1. Well, now I can list all my solutions. What are my solutions? 3, negative 2, negative 1. And what do you notice? Where do all those come from? Yeah, we got positive 3. We've got negative 2. We've got negative 1. Comes right from our choices. If there are rational roots, they're going to be from your choices, your P's and Q's. You need to try one on your own. Try number 2. Go. You can do it. You're really smart. Third degree, my P's, 1, 2, and 4. My Q's, 1. My choices are plus minus 1, plus minus 2, plus minus 4. So that means if there are solutions, they must be one of these 6. I try 1, and 1 works. 1 plus 3 minus 4 is 0. That means that x minus 1 is a solution or a factor of the polynomial. X minus 1 is a factor. 1, 3, 0, negative 4. Drop the 1, multiply, add, multiply, add, multiply, add. So it factors to x minus 1 times x squared plus 4x plus 4. And I saw a lot of people factors get x plus 2 times x plus 2. Just one small thing, when you do list your solutions, please list 1, but then please list negative 2 twice. That shows that it's a double root, because that will behave differently with the graph. If I asked you to graph this, would you be able to graph it? Now, hopefully you feel like, after Friday and Thursday that you can. It bounces off of negative 2 and passes through 1. That's what the graph looks like. So all of a sudden we come up with great ways to graph polynomials. Last example for the day. I'm going to give you an assignment today. However, you are not going to get a new assignment tomorrow. Tomorrow you're going to have a lot of time in class to work on this assignment. All right? Fair game? Lots of time tomorrow to work on it. All right? So here we have it. Last problem, number 3. What's different? Yeah, there's a 2 in front. So the degree is 3. My P's are 1 and 3. My Q's are 1 and 2. So you got to take each of the P's and divide it by each of the Q's. This is something that's not very difficult to do, but people mess this up on the test. So please be careful. I'm going to take the first P, which is 1, and divide it by each of the Q's. So I end up with 1 over 1, which is 1, and 1 over 2, which is a half. After I did 1, I move on to the 3. 3 divided by 1 is 3, and 3 divided by 2 is 3 halves. Now, there are some choices that are bad choices. Can anybody think about the problem and tell me what would be a not good choice? Positives, why? B lock A. You got to make 0. You got to have a negative somewhere, right? So all of a sudden, he was able to wipe out half of the choices. Don't plug in a positive. You ain't going to get 0. So what do we want to start with? Negative 1. Negative 1 cubed is negative 1 times 2 is negative 2. Negative 1 squared is 1 times 9 is 9. Minus 10 plus 3. Does that give me 0? Sweet. That means that x plus 1 is a factor. Take that negative 1 and drop it in. 2, 9, 10, 3. Isn't synthetic division awesome? He used the word love. He didn't even use like. I appreciate your enthusiasm for mathematical things. We have x plus 1 times 2x squared plus 7x plus 3. Does 2x squared plus 7x plus 3 factor? Jeez, DeWalt. Perhaps. Yes, perhaps everything factors. This does factor. And we get solutions of negative 1, negative a half, and negative 3, which you can see them all sitting right here. And as we said, they would all be negative. Look at that. Some of you remember this from Advanced Algebra 2. You should have seen an introduction. In Advanced Algebra 2, you looked at this much of the fundamental theorem of algebra and the rational root theorem. We are going to put it on steroids in this class. Yes.